All right, Northern Oklahoma College, Math 1513. This is College Algebra, Chapter 1, Section 4. We're solving radical equations. What is a what is a radical equation? Radical equation is anything with a square root. We call it radical. All right, so a radical equation looks like this. All right, here's your square root, which we call radical. The whole idea is it's throwing one more step in there into solving these equations. What do? Well, we have a 3 to get rid of, we have a 10 to get rid of, and we have a square root symbol to get rid of. Now, what do? I usually get rid of what's furthest from the x. There's my fence on my equal sign. Okay, what's furthest from the x? The 3. So I'm going to get rid of the 3 first. I'm going to call that number 1. I'm going to get rid of the 3 first. Then I'm going to get rid of the square root sign because the 10 is actually closer to the x than the square root is. The square root's over both of them. So I'm going to do that. Step 2. And then step 3, I'm going to get rid of the 10. Now we're going to have a negative sign by that x when we're done. I'm going to call that step 4. So you see what I'm doing? I'm just eliminating things on that left side of the equation. I'm eliminating everything by the x, starting with the thing that's furthest away. All right, let's do that. So the first thing I'm going to do is subtract 3 from both sides. Then I have square root of 10 minus x, or radical 10 minus x equals 4. Some people call this isolating the radical. When you get the radical alone on that side of the equal sign. All right, next I'm going to get rid of the square root, and we have to think about what undoes a square root. Remember, a square root, if I put a little square root symbol here, a square root actually has a little 2 in the corner there. We just never write it because we use square roots so often. So what undoes a second root or a square root? Raising something to the second power, or squaring it. So squaring undoes the square root. So to undo this square root, I'm going to square it. Have to make sure I do it to both sides. This square cancels out that square root, and all we have is 10 minus x. On the right side we have 16. Next I'm going to get the x alone by getting rid of that 10. And I have x, now don't forget there's a negative sign by it, or a minus, same thing, equals 6. And my final step, probably the easiest way, is to divide both sides by -1. You can think of that negative x as being a -1x if you want to, and we're just dividing that -1 off. And you also could have multiplied by -1. It works the same way. And our final answer is x equals 6. Okay, how about we do the math right here? X equals -6. There we go, x equals -6. Now one more thing. You always check your solutions to radical equations. So I'm thinking about my answer, -6, and I'm going, I wonder if that works. So I check it, and I plug in my -6, and I have square root of 10 minus -6 equals 7. Underneath the radical, I have 10 minus -6. That turns into less, so 16. We have a square root still there because we haven't taken the square root. Square root of 16 is, well, the square root of 16 is 4 is what I was getting ready to say, but I had to go back and fix my equation. I forgot to put my plus 3 on there. Square root of 16 is 4 plus 3 equals 7. 7 equals 7, and that checks. All right, our next example is for your assignment number 29. Square root of x plus 7 minus 2 equals square root of x minus 9. Now the usual first step on solving radical equations that have more than one radical sign in them is to make sure that you isolate one of the radicals. Make sure that one of the radicals is alone on its side of the equation. All right, and if you look at our equation, there's our equal sign. We have a radical over here with a number. I mean, that's not great, but it's okay. The important thing is this radical is isolated. Now to solve these equations, first we have to get one of our square roots isolated because we're getting ready to square both sides. All right, let's do that. I'm looking at this square root and I want to get rid of it. So I get rid of it by squaring. Now to do that, I have to group all of the things on the left side into parentheses and square the whole batch. I can't just square a piece of it. I squared the entire right side on the right side of the equal sign, so I need to square the entire side on the left side of the equal sign. Now remember what we said, when you square a square root, they cancel each other out. So on the right side of the equal sign, I just have x minus 9, and we've gotten rid of one of our radicals. That's good. Now the hard part is foiling our left side. It's going to turn into a foil. I'll show you how. So we have square root of x plus 7 minus 2, and it's squared, which means we're just multiplying it times another one. So when you square something, you're just multiplying it times itself. So it's a radical x plus 7 minus 2 times another radical x plus 7 minus 2. All right, let me get this out of the way. All right, let's FOIL. So the first thing I'm going to do is multiply the first term times first term and first term times second term. Square root of x plus 7 times square root of x plus 7 is square root of x plus 7 squared. Now, square root of x plus 7 times negative 2, we're going to write this way, negative 2 square root of x plus 7. Because it's negative 2 times the radical, or the radical times negative 2. We like writing the negative 2 first. Next, I'm going to multiply the negative 2 times that radical x plus 7, which gives us a negative 2 square root of x plus 7, like we just said. And finally, I'm going to distribute the negative 2. Negative 2 times negative 2 is positive 4. And on the right, we still have x minus 9 waiting around. Let's simplify a little bit. If you'll look at this term right here, we are squaring a square root. When you square a square root, they eliminate each other. They're inverses. So I just have x plus 7 there. If you'll look here, whenever you FOIL, these two middle terms usually end up being like terms. So I have a radical x plus 7 and another radical x plus 7. I just need to add their coefficients. So a negative 2 minus 2 is negative 4. That's the coefficient of this radical here. So I had negative 2 x plus 7s and then negative 2 more x plus 7s for a total of negative 4 radical x plus 7s. I still have my plus 4, and I have my x minus 9. Okay, that's a good first step. So the first thing we did, remember, let's review, is we isolated this radical up here. We isolated the radical. It was already given to us that way. And then we squared. Now what are we going to do? We're going to isolate the radical again. And square again. Okay, we've already done it once. We're going to do it again. That's how you get rid of radicals. You isolate them on one side, and then you square everything, and it makes the radical go away. All right, so we want to isolate this radical right here. Let's see if we can do a little simplifying first. Now on the left side, I see a positive 7 and a positive 4 that I can put together. So when I add like terms, it looks to me like, I'm going to write the radical first because it'll seem a little more organized if we put the radical out front. Negative 4x plus 7, and then I have my positive x, or plus x, and I put my plus 7 and my plus 4 together to get plus 11. And on the right side I have x minus 9. Okay, let's review what we want to do. We want to get that radical alone. I'm going to put red on the radical here. Just to remind ourselves, we're trying to get that square root alone. That means we have to get rid of the negative 4 and the x and the 11. Remember, there's my fence. So I need to get rid of those three things to get that radical alone. What order do I get rid of them? I usually get rid of what's furthest away first. So I'm going to get rid of that first. I'm going to get rid of that second. And I'm going to get rid of that third. I'm going to go in that order when I get rid of things. All right, so let's get rid of the 11. I minus 11 from both sides, and I have negative 4 square root, I'm just writing it in red so you remember that's what we're trying to get alone. Negative 4 square root of x plus 7 plus x, because the 11's gone, equals x minus 20. Negative 9 minus 11 is negative 20. Next, I want to get rid of the x. And I have negative 4. Remember, we're trying to get the square root alone. X plus 7 equals, those x's are gone, negative 20. And finally, my third step was to get rid of that negative 4. Now remember, we are multiplying right here, so to get rid of times negative 4, I divide by negative 4. Same thing on this side. Cancel, and I have square root of x plus 7 equals 5. Okay, we did all that to get the radical alone. Now that we have the radical alone, we get rid of a square root by squaring. So I'm going to square both sides. Remember, when you square a square root, they go away because they're inverses. They undo each other. So we have x plus 7 equals 25, and we minus 7 to get x equals 18. Now remember, it's very important to check radical equation. Alright, so I test my x equals 18. I take out the x and put in 18. We're going to see if it works. And over here I take out the x and put in 18. We're going to see if it works. And we get square root of 25 minus 2 equals square root of 9. Well, that's 5 minus 2 equals 3. And we can see that that's true and that's going to work. So x equals 18 works and checks out. Okay, here's another sneaky little problem you might see with radical equations. I'm going to work this really fast because you guys know the steps now. First step is to isolate one of the radicals. Alright, and I do that. I'm going to get rid of the 2x plus 6. So I add radical 2x plus 6 to both sides and get this. Now I can square each side. Remember, a square cancels the square root on this side. Alright, and on the right side, when I square 3 minus radical 2x plus 6, it's 3 minus radical 2x plus 6 times another one, which we're going to use FOIL to multiply out. And we get this when it's all FOILed out. Now I'm going to add the like terms in the middle, and I'm going to square that term on the end. It gives me this here. Now I'm going to add like terms on the right. And now I'm going to isolate the radical again, which means I have to get rid of this, and this, and this. I'm going to do it in this order. 1, 2, 3. Going to get rid of those, and my radical will be alone. Minus 15 from both sides gives us this. Minus 2x from both sides gives us this. And dividing both sides by negative 6 isolates the radical. Once you have the radical isolated, remember now, we can square both sides. That was the whole point of getting the radical alone. 16 equals 2x plus 6. I'm going to get rid of the 6 and then get rid of the 2. And so minus 6 from both sides, 10 equals 2x. Divide both sides by 2. And get x equals 5. Now don't stop here and think that you're done. Remember, with radicals, you always need to check. So I write down my original equation. I take out the x's and I replace them with 5s, and let's work it out. And I get square root of 1 plus square root of 16 equals 3. Square root of 1 turns into 1. Square root of 16 turns into 4, and it's supposed to equal 3, does it? We get 5 equals 3, does it? No, it does not. So since 5 does not equal 3, there's no possible solution.